Hello and a very good evening to all the students and viewer. Welcome to the YouTube live session by ACE Engineering College. Right? So here our main aim or main motto is to help the student while they are writing the exam. So what I am going to do here? So today we are going to discuss some of the very important topics and some previous university questions which are repeatedly asked in the examination, right? So here we are going to tell you how you should write the exam. What happened is sometimes some students know the answer, so they keep on writing, and when they don't know, they just skip it. So you should not do that. Your target is to complete all the question in the stipulated time. So here I am going to tell you what to write, how to write, and how you should approach for a question. If you know the question, attempt it in the first. You don't know, keep it for the end, but don't skip it. You should write, but how we should discuss here, right? So without any delay, let's start it. So my name is Shibajee Sutar. I am working in ACE Engineering College in Department of Civil Engineering as an assistant professor, right? So today I am going to deal the subject called strength of material 2. In your college there may be only strength of material, but don't worry, we'll see. So today which topic we are going to see? Today we are going to see the topic called torsion. This topic not only help for the civil engineering student, but this topic is present in the for mechanical engineering also. For mechanical engineering also, they have strength of material or mechanics of solid subject. In that, this topic must and should be there. This is that important, right? So without any delay, let's start it. So today's topic is torsion of a circular shaft. Most of the universities, they only limit the discussion of torsion is in circular shaft. Okay, so let's see what is torsion, how it is developed. So if you consider any shaft, when you apply equal and opposite amount of torque in both the ends of a shaft, then what will happen? Then the shaft will be under torsion. So if you see, this is a shaft. Here if I apply a torque T, and here also if I apply a torque T, both magnitude should be same but direction will be opposite, then each and every element here in the shaft is subjected to torsion. Right. Now what happened when you give torque? We know it will subjected to torsion. So if you take any strip here, imagine you have considered this strip. If I draw it here, if you see this strip, due to the torsion, there will be a generation or development of shear stress tau. This shear stress is nothing but torsional shear stress. This shear stress is nothing but torsional shear stress. Okay, this is nothing but torsional shear stress. So obviously if this developed here in the opposite direction, to balance it, here also another shear stress will develop. So many students think that this body is in now equilibrium, but if you see carefully, due to this two shear stress, there is a development of anti-clockwise moment also. So to balance this one, what will happen? Automatically in this body, another two shear stress will develop, that is called complementary shear stress. This is called as complementary shear stress. Complementary shear stress. right? Okay. Now, due to this complementary shear stress, what will happen? This will try to develop a clockwise moment. Now this body is in equilibrium. So here the important thing is this torsional shear stress developed due to the application of torque T. So there must be a relation between applied torque T and this developed shear stress. So the main important thing is here to find the relation between this torque and this torsional shear stress, right? So now we are going to find out that relation. But before that, we have some assumptions in torsion derivation, right? And this assumptions is one of the most important question in your university exam. If you see carefully previous university exam, many times for short answer type, maybe for 2 marks, maybe for 3 marks, they are asking this question repeatedly. Explain or list out the assumption made in the torsion derivation. So next we are going to see that one only, that is assumptions in the derivation of torsion formula. What are the assumptions? So basically there are only 4 assumptions. If you write only those 4, sufficient for your exam, you will get the full marks. The first assumption which we use always from start to end in strength of material, that is the material is homogeneous and isotropic. The material is homogeneous and isotropic. This should be your first sentence, right? Next, the material or the stresses developed in the material will be under elastic limit and it must obey Hooke's law. See here, the stresses are within elastic limit and it will obey Hooke's law. Everybody know Hooke's law, I hope. Hooke's law is nothing but stress is proportional to strain within proportionality limit. So this is the second one. Next, coming to the third important assumption. What is the third important assumption? The third important assumption is the circular cross section remain plane and perpendicular to the axis before and after twisting. Once the shaft get twisted, the cross section of the shaft should remain same before and after twisting. This is the third assumption. And the last assumption is the length and radius of the shaft remain constant. Remain constant. Which one? Length and radius after twisting. Now, this is the important one to understand here. We all know that we use or we see torsion in our day-to-day life. Yes or no? Yes. Where we see, suppose you washed your cloth, right? And if you want to drain the water, what you do? You hold the cloth and you apply torque from in the both ends, from this hand in the front, this hand from the back, and you twist it. The moment you twist it, what happened? The water drained, but at the same time, the length of the cloth decrease and the radius of the cloth also decrease, right or not? Yes, if you observe, you might have seen that. But in case of shaft, that much twisting is not possible. That is why the length and radius will always remain same. Even though in the question they may give you that it is twisting by this amount, that amount, but while we derive the torsion formula, we need to keep in mind that length and radius will not change. It will be remain constant. Very important. Okay. So this is a small 2-3 marks question. You may expect this question maybe in 2 marks or 3 marks in your university exam. Very important. Now let's see because in this chapter or in this topic, there is only one formula. And if you know how to derive it and if you know how to analyze that one, everything is very easy. Very easy. You can solve any question from this chapter, right? So let's see now how to derive the torsion formula. And I am telling you, my friends, this question, derive torsion formula, you choose any of the university paper throughout India. There must be one question, derive the torsion formula, 10 marks, sometimes 15 marks, sometimes 8 marks, based on different university. But this question is very, very common and very, very frequently asked question. So let me show you how easily you can solve this and you can easily get 10 marks. So now you see how I write it. In university, you have to write it neat, clean, and you have to present it so well that there should not be any mistakes. And even though like the examiner who correct your paper, he or she should get impressed and give you the full marks, right? The paper should talk. So let's see how to derive the torsion formula. How to derive the torsion formula. So to derive the torsion formula, see here, I have considered one shaft. Okay, I have considered one shaft. This shaft is having a length L. This shaft is having a length L. Let it be from this point to this point. The length of the shaft is L. Okay, length of the shaft is L. Now you consider this shaft will made up of n number of elements. Consider one small element here. So I have considered this small element. Let this element name may be A. Here I name it as B. Now what you do is you apply a torque here. You apply a torque here. So this is the torque. Okay, and here this element is at a distance of r from the center of the shaft. Now you have applied a torque. The value of the torque may be. Tell me what happened. The moment you apply torque in it, what will happen? This element will try to deflect or deform. So let us see that the deformed shape is this one. Previous shape, before applying the torsion, AB is the element. After applying the torsion, the same element is deformed like this, and it reached to a point where I name it as B dash. B became B dash. A end is fixed, so here it doesn't change. Right? Now again, this is also, it deformed, but since radius and length will not change, this is also at a distance of r from the center. Let it be O. Okay, let it be O. Now you see here there are two angles. This angle, this is a angle. This is called theta. What is theta? I will tell you. Theta is angle of twist. And here if you see there is another angle. Here if you see there is another angle. This angle is gamma. Now let's write what are all those things. So I am writing here, let the length of the shaft is equals to L meters, right? Length of the shaft I know. Next, what is R? R is the radial distance. R is equals to, small r is equals to radial distance of the elemental strip. Right? Okay. And what is theta? I told you. Theta is angle of twist. What is angle of twist? Angle of twist means how much, due to the applied torque T, how much that shaft twisted. That is angle of twist. Now coming to very important, then what is gamma? Gamma is nothing but shear strain, or you can say torsional shear strain. This is nothing but shear strain, right? So it is very easy up to here. Very good. Now you see how I derive it. So to derive torsion formula, you need two equations. One is compatibility equation, other one is equilibrium equation. What is compatibility equation? Compatibility equation is balancing of deformation. And what is equilibrium equation? Equilibrium equation is balancing of forces and moments. So let's use compatibility equation first. So I am going to use now compatibility equation. Compatibility equation. Now if you see, this shaft is twisted. So let me consider this portion first, that is A, B, B dash. So I have drawn this part here. This is A, this is B, and this is B dash, right? And you know this angle is gamma. What is this length? L. This length is L. Now, can you tell me what is the arc length BB dash from this figure? Very easy, we know arc length is equals to the length multiplied with the angle. Yes or no? So if you see here, I can easily write arc length BB dash is equals to what? BB dash is equals to L into gamma. L into gamma. This is my equation number 1. This is my equation number 1. Now you see, if I consider this part, right side, left side over, now you see right part. Right part is having OBB dash. So consider that part. This is OBB dash. OBB dash. Now if you see, this angle is nothing but theta. Yes or no? Yes. Now again I want to find out this arc length, that is BB dash. What should be the arc length BB dash? So again you can write arc length BB dash is equals to how much now this time? Now if you see this one, O2B dash and O2B, the length is given to you R. So simply you can write this is nothing but R theta. This is your equation 2. Now I know equation 1 and equation 2. If you see, left hand side is same. So can we equate? Yes. So you can write equate equation 1 and 2. If you equate equation 1 and 2, simply you can write L gamma must be is equals to R theta. Yes or no? Yes. Now from here, can I write gamma is equals to R theta by L. R theta by L. What is this gamma, my friends? Gamma is nothing but shear strain, torsional shear strain, right? Now if you remember, in the assumption I told you that this shaft will obey Hooke's law. So if you apply Hooke's law, if you apply Hooke's law, what you know? Hooke's law is nothing but stress is proportional to strain up to proportionality limit. But here, what is the stress developed due to torsion? Due to torsion, shear stress developed. Shear stress must be proportional to shear strain. Yes or no? If it is normal stress or normal load, then normal stress will develop. Normal stress is proportional to normal strain. Here shear stress develops, so shear stress is proportional to shear strain. Now, to remove this proportionality limit, I need to use some elastic constant. You know, when normal load is acting, normal stress will develop. E is the Young's modulus, and that is the elastic constant. But for shear stress, the elastic constant is G, modulus of rigidity, or you can say shear modulus, G gamma. Now you see what you can write. Tau is equals to G. What is gamma? Gamma we already find out from here. R theta by L. Yes or no? Gamma is equal, tau is equals to G is same, gamma R theta by L. So this is nothing but my torsional shear stress. This is nothing but my torsional shear stress. Now, if you rewrite this equation, you can write it like this and you will get this one. Tau by R must be is equals to, tau by R must be is equals to d theta by L. So this is the finding from the compatibility equation. So this is my equation number A. This is my equation number A. I hope it is very easy just by considering the deformation BB dash. That's what compatibility equation, equating the deformations. I did and I got this result. Right? Now I have to use equilibrium equation, I told you, right? So this is, I hope everyone understood. Very good. Now let's see how I use equilibrium equation. See, now same shaft. This is the torsion T. This is R. This is R. 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 This is O. This is theta we know. This is A, B, and after deformation it became B dash. This is my shear strain gamma, and from here to there the length is L. From here till the end the length is L. Right? We know all these things. Now I will use equilibrium equation. Equilibrium equation. Now what is equilibrium equation do? Equilibrium equation deals with balancing of forces and moment. So if you see here in this shaft I have applied a torque, right or not? So if this system has to be in equilibrium, I have to say what? Applied torque must be is equals to resistance torque developed in the shaft, right or not? So what will be my equilibrium equation? I can write my equilibrium equation is torque, applied torque in the shaft must be is equals to resistance torque developed in the shaft. Yes or no? Yes. So if I equate this to, I will get another relation. Now you see, we know applied torque. What is the applied torque value? T. But I don't know what is the resistance torque. So now how we should find out resistance torque? So see here, consider this cross section. Okay. So here, just give me a second. Just 1 minute. Yeah. Now, here I consider the cross section of the shaft. This is the cross section, and we know in the cross section of this shaft, the applied torque is T. Now, here is the axis of the shaft, right? The red color line shows the axis of the shaft. Here I considered one elemental area. Let this, I call it as elemental area. Elemental area. Now, we know that this shaft is made up of small elemental area. First, what I will do, I will find out the resistance offered by this small elemental area. Then I will find out what is the resistance offered by the complete shaft. Okay, so this is the elemental area having the area called dA. The area value is dA, right? So let's write what is the force resisted by this elemental area, and we know this elemental area is placed at a distance of r from the axis. So first we will find out what is the force offered or force resisted by this small elemental area. So force developed in the elemental area, is equals to dF. What is force? What is force? We all know stress. What is stress? Stress definition is different. Numerically, we write it as P by A, force by area. So force will be is equals to stress into area. What is stress developed in the shaft? The stress developed is shear stress. And what is the area of this elemental strip? dA. So this is force offered by the small elemental strip. Once we know force, can we write what is the twisting moment developed in the elemental area? Twisting moment developed in the elemental area is equals to dt. What is moment? Force into perpendicular distance. We know what is the force. Force is dF, and dF is at a distance of r from the axis, right? So I can write dt, torsional moment developed, resistance moment developed in the elemental strip is nothing but tau dA into r. Yes or no? Tau dA into r. Now I know this is the resistance moment developed in one strip. To know the resistance moment developed in the complete shaft, what I have to do? Just integrate it. So I can write resistance torque developed in the shaft, how I can get it? Just integrate it is equals to dt is equals to tau A into R. So to get this one, just integrate this term. To integrate, if you integrate, what you will get? Integrate, integrate. Now, integration of this one is nothing but t is equals to, yes or no? This one, tau dA into R. If you see, here I got one value for tau. See here, tau is equals to gr theta by L. So let's put this value over there. So now see here, tau is equals to gr theta by L. This is tau into dA into R. Yes or no? Yes. Now you see here, T is equals to this one. If you see here, g theta by L, g constant value, length of the shaft will not change, theta will remain same for this one. So theta also I will take it out. So I can write T is equals to g theta by L integration R square dA. This is very important. You may have learned this term in engineering mechanics. R square dA, this one, this term, R square dA is nothing but, it is polar section modulus. What it is? Polar section modulus. Sorry, polar moment of inertia. Sorry, mistake. It is polar moment of inertia. Polar moment of inertia. Polar moment of inertia. So I can write T is equals to g theta by L into polar moment of inertia, that is J. Polar moment of inertia, that is J. Now what is the relation? I can write it from here. So I am writing it in the next slide, that is T is equals to g theta by L into J. So from here I can write T by J is equals to g theta by L. So see here, I got another equation and I name this equation as equation B. So using equilibrium equation, I got one relation, and using compatibility equation, I got one. So from this I can write by equating, if you remember what is the value I got? That is, I got it like this, right? From compatibility equation I got tau by R is equals to g theta by L. Yes or no? Yes. So this is my equation A. This yellow one I got it from compatibility equation. This one I got it from equilibrium equation. Now equate equation A and B, we get what I will get if you equate. See here, I can write it like this. I will get T by J is equals to tau by R is equals to g theta by L. So this is the torsion equation. This is the torsion equation. Very, very important. Every time most of the universities, they ask it for 10 marks. So if you Follow this one, it is very easy, very easy. Compatibility equation and equilibrium equation, you can get this relation, right? So here, what is tau? Tau is torsional shear stress, torsional shear stress. Yes or no? Yes. Next, then what is L? Length of the shaft. Length of shaft, we already discussed this one. Yes or no? Theta is angle of twist. Angle of twist, and we have to take this angle of twist in radian. They may give you in degree, but you have to change it to radian. Next, what is R? R is equals to radial distance. Yes, I told you this one. Here, next is T. What is T? Torsion or torque, or you can say constant torque over the length. So if you do any mistakes by chance in exam, here I have eraser, but in your case when you write with pen, you don't have a eraser. So just strike it and write again. Don't put all the cut marks randomly. Just a small cut. That's it. That's enough. Constant torque over the length. Next, the important one is J. J is polar moment of inertia. Polar moment of inertia. How to find out polar moment of inertia? It is simple. That is Ixx plus Iyy. Now, since the topic itself is the circular shaft, so the most of the case you will get a circular cross section, right? So if it is a solid circular cross section, what is Ixx? Pi d power 4 by 64. Iyy also pi d power 4 by 64. If you add this two, you will get J is equals to pi d power 4 by 32. That is for solid circular shaft. Solid circular shaft. But for hollow, there will be two diameters. You know, right? So just you have to apply this formula, you will get the result. So with this, torsion derivation is finished. I hope you like it or you feel it is easy. That is my task, to make the things easy, right? If it is easy, that means you have understand well, right? Now, this is very important. Every time one question comes. Now we'll see some one or two important observation. This important observation is required because small 2 marks question may come from this. That is, we know this is the formula for torsion. T by J is equals to tau by R is equals to G theta by L. If you consider this first half, observation number 1, if you consider this first half, that is T by J is equals to tau by R. You know that torque will not change. For a length, torque will remain constant. J, material property, based on the cross section, so cross sectional property. Based on the cross section, J will be there. So J will also not change. R may vary. From the axis, you may take the extreme point, you may take middle point, you may take the innermost point. So R will vary. So if you see, for a given shaft, this one is constant. If this one is constant, I can simply write tau is proportional to R. That means as the radial distance increases, what happened? Your shear stress will also increase. So if you consider a shaft, what happened if this is the shaft? This is the axis of the shaft. Yes or no? Yes. We calculate R distance from the center. So as R increases, your shear stress also increases. At this point, R is equals to 0, right? So if R is equals to 0, shear stress also will be 0. Or I can say if R is minimum, shear stress also will be minimum. But at this point, R is maximum, right or not? If R is maximum, shear stress also will be maximum. So how you can draw the shear stress distribution over a shaft? See here. If this is the shaft, this is your axis. This is the point where R is minimum. This is the point where R is minimum. Or I can say it is 0. And this where R is maximum. So maximum stress will develop here, and as soon as you come near to the center, it will be minimum or 0. And how will be the variation of shear stress? The variation of shear stress will be linear. Variation of shear stress. Variation of shear stress is linear. Very important, linear. It will always be linear. See here. This will be the shear stress variation. Here tau max, and here shear stress will be minimum, tau minimum. Right? Very important observation. Right? Next important observation, if you see, observation number 2. Observation 2. What is the observation 2? Observation 2, we'll see this one. T by J, this one and this one will equate. G theta by L. G theta by L. From here, if you find out theta, what you will write? Theta is equals to TL by GJ. So here, very important relation between theta and GJ. What is this GJ called? GJ is called torsional rigidity. Torsional rigidity. So here I can write theta is inversely proportional to GJ. Means what is torsional rigidity? How rigid it is. That means if very rigid, there will be less deformation. If less rigid, more deformation. So for a shaft, if GJ is more, if you make a shaft whose torsional rigidity is very high, then it is very difficult to twist. It is very, very difficult to twist. Okay, so this is my observation number 2. Third observation, observation number 3. Observation number 3, these are very important concept. You have to know. Otherwise, you cannot solve problem. That is why this may not ask you directly. They may not give you the question directly, but they may give you a question, define torsional rigidity. So you should able to define as well as mathematically you should show, right? So that is the reason I am explaining here. Now observation number 3, it is related to called shaft strength. It is related to called shaft strength. Most of the time this is the concept from which more number of questions appear. Now you see, we know the formula T by J is equals to tau by R. Now can I write it like this? T is equals to tau into J by R. Yes or no? Now from here we know that for a given torque, the maximum shear stress for a given torque, the maximum shear stress will develop at what point? When R is equals to R max. So I can write when R is equals to R max, tau will be maximum. So this one, J by R max, this term J by R max is called as polar section modulus. This one is called as polar section modulus. So I can write T is equals to tau max into this one, polar section modulus, is denoted as ZP. It is denoted as ZP. So this is a very, very important formula. T is equals to tau max into ZP. Sir, why it is important? Why you are saying that this is very important? So see here, the main important thing here is, suppose I have two shafts. This is shaft number 1. This is also second shaft, shaft number 2. Two shafts. Two shafts are there, right? Made with same material. So I can say for a given torque, what happened? What happened is both will reach to its maximum stretch. Like allowable stress will be same. So I can write, let it be T1, T2. Correct? This will generate tau 1, tau 2. This is same material, but based on the size and dimension, this will have ZP1 and ZP2. Sorry, let it be ZP1 and ZP2. But if the material is same, tau 1 will be equals to tau 2. If material same, if we use same material, tau 1 will be is equals to tau 2. Why, sir? Because it is a same material. Both steel, if fail by 10 kilonewton load. So imagine if you have a shaft which will fail made up of steel, and if it is failed by 10 kilonewton per meter, 10 kilonewton meter torque, then every time it will fail in that only, na? Steel. So this will be same. So if I write with this relation, who will carry or what will be the torque carrying capacity, I can write like this: T1 is equals to tau 1 ZP1 by tau 2 ZP2. So here tau 1, tau 2 will get cancelled because it is same. So you will get a relation like this: T1 by T2 is equals to ZP1 by ZP2. This is a very, very important relation from observation number 3, that is called shaft strength. And the last observation, that is observation 4. Observation 4, that is very easy, all of you know also: power transmitted by shaft. Power transmitted by shaft. So what is the formula for power transmitted by a shaft? P is equals to 2 pi nt by 60. P is equals to 2 pi nt by 60. Now here, this formula is very, very important. Sometimes direct questions come. They will give you all the data, P, N, everything will be given. They may just ask you, find out the torque carrying capacity of the shaft. So just use this formula and you will get the result, right? So let's see, these all are the concept, my friend. First we discuss assumption, which is very important. Then I given you torsion formula. Torsion formula, 99 to 100% it is asked in all the university exams. So torsion formula derivation is over. Now all this concept I told you because now we are going to solve one problem. This will help you there. Okay. Now let's see how you can solve this one. See here, what is the question given to you? Read this question one time. What is the question given? The question given is that there is a shaft Yes. Can you read this question? Yeah. Determine the diameter. They have asked in the question, determine the diameter of solid shaft. They have given you that shaft is solid and you have to determine the diameter. Whenever they ask you determine the diameter, that means you are going to design a shaft. Designing a shaft is nothing but finding out its diameter or finding out its length. Let's see. Determine the diameter of the solid shaft which will transmit a power of 800 kilowatt. So here let's start with the solution. So always remember students, when you write for final exam, you have to write it very systematically so that your paper looks very good. So first you write with given data. Sometimes if you don't know and if you write given data, you may get 1 or 2 marks. Just how you present that catches marks. So given data, what is the given data? They said there is a shaft which transmits a power of 800 kilowatt. 800 kilowatt, right? Yes, it is carrying a 800 kilowatt. So you can change into what? That is 800 into 10 power 3 watt. Next, what they have given? At a 250 RPM. That means N also given to you. N is equals to 250. Next, the maximum shear stress and angle of twist should not exceed more than 30 MPa and 1 degree. So they have given tau max is equals to 30 MPa. They have given you tau max is equals to 30 MPa and they have given you theta is equals to 1 degree. They have given you theta is equals to 1 degree. What they said? Assume the length of the shaft is 2 meter. Length is also given. Length is also given, that is 2 meter. You can change into mm or not? Yes or no? Yes. If you want, you can change into mm at the later stage. 2 meter is equals to 2000 mm. Right. Length also over, and they have given modulus of rigidity, that is 1 into 10 power 5 megapascal. They have given all this data to you. What they ask you to find out? Find out the diameter. Diameter, and what type of shaft it is? It is a solid shaft. These things they have given. Now how will you solve? Very easy, na? Because I have given you the formula. First, we know power is equals to 2 pi nt by 60. See power P given. Yes or no? What is given? 800 into 10 power 3 power. 2 is a number. Pi. N is again given 250 RPM. So rotation per minute is given, that is 250. Torque I need to find out from here. T I have to find out from here, divided by 60. So use calculator. If you use calculator, you will get the value. T is equals to 3055 7.74 Newton meter. If you want to change into mm, you will get the same value, 30557.74 Newton mm. Okay, right. So this is the torque. Sorry, 74 into 10 to the power of 3. Here I did a mistake. Here it should be into 10 power 3, na? Newton mm. Newton mm. Newton mm. Right. Okay. Correct, na? Yes. Now once I get torque, half of the problem over. Now they have given me tau max. You know, just now I told you that for a given torque T, tau max, when it is possible when Z R is equals to R max, right? So I told you into J by R max. Now here you imagine that this is the solid shaft, okay, and it is having a diameter D, which I am going to find out, right? Now you know this is the axis of the shaft, yes or no? For this circular shaft, we know what is J. J is equals to tau max into what is J? I given you, right? Pi d power 4 by 32 is the J. What is R max? From the shaft, R max will be this distance, na? This is my R max, and you know that R max will be equals to d by 2, because the axis of the shaft will pass from center. So here it will be d by 2. So if you solve this one, you will get what? You will get tau max is equals to T by pi d cube. We'll get tau max is equals to 16T by pi d cube. Now once we know this one, the relation, can we put the value and get the tau d value from here? Yes. Tau max is given in the question, that is 30 MPa. All of you, MPa is nothing but Newton per mm square. Newton per mm square, right? So you have to put everything into Newton mm. That's why I convert this Newton meter to Newton mm here also. Now 30 is equals to 16 into T, 30557.74 into 10 power 3 divided by pi. Pi is pi and into d cube. So you have to take this term here, cube root, get the value, or use calculator. If you use calculator, I hope you will get this value 173.11 mm. This is the diameter. We get it by using tau max, but don't use directly this one. You have to check for this condition also. 1 degree, they told you na, that the maximum shear stress should be this much. At the same time, you have to check the angle. So here, till now what we did it for strength based design. This is nothing but strength of the shaft. To carry 30 MPa, the diameter should be 173.11. Now we have to see whether to get only 1 degree rotation or 1 degree angle of twist, how much should be the diameter. So second one is this design, what I did just now, I call it as, this is strength based design. This I call is at strength based design. Now I have to check stiffness based design. Means design based on the stiffness. Theta is nothing but stiffness. How only 1 degree rotation is allowed. So stiffness based design now. Just give me a second. Okay. Now next is stiffness based design, right? So for stiffness based design, I have to use the formula. Can you tell me? Stiffness based design. So I have to use one formula in which theta is involved. Which formula is it? Which formula? If you remember the formula of theta, theta is equals to what I given to you? TL by Gj, and I told you you have to use theta always in radians. So theta is given 1 degree. So 1 into radian pi by 180, yes, is equals to T, you know, that is 30557.74 into 10 power 3 into length of the shaft given 2000 mm, G given 1 into 10 power 5, and what is J? J you can write pi d power 4 by 32. Right or not? So see here, everything is known except D. So if you find out D from here, you will get D is equals to 137.42 mm. Now is the important question. I got 2 diameter. This is one diameter. This is another diameter. Which diameter I should choose? Should I choose 173.11 or should I choose 137.42? So see here, if you use 137.42, that means if I use this diameter, the maximum deformation it will happen is 1 degree. But will it satisfy the other condition, that is 30 MPa? If you give 137.42, can it sustain 30 MPa? No, because we find out to sustain 30 MPa, the minimum diameter I have to present is 173.11. So if I present 173.11, it will sustain 30 MPa. At the same time, the deformation will be less than 1 degree. Why? Because if I put 137, this one, then only 1 degree will come. But I am putting more than this. That is why it will verify, or it will prove that it will sustain 30 MPa shear stress, as well as the theta angle of twist will be less than 1 degree. So which one you should choose? You should choose, therefore, the diameter of the shaft must be the diameter of the shaft must be equals to 173.11 mm. Greater from both the value, which one is greater, you should choose always that one in design, right? So here I will stop today. Time is up, but I hope you liked it. If you have any doubt, kindly comment in the comment section. You please write your doubt. Next session when I will come, I will try to clear all those doubts. And I want to tell you something. Every Saturday we'll have the different courses, classes like this. Like in civil engineering, different subjects are there. Today SEM 2, strength of material 2 is there. Next, some other subjects will be coming every Saturday. Please stay tuned. If you like this one, kindly share this. Kindly give a thumbs up if you like it. Kindly share it with your friend. And don't forget to subscribe the channel of ACE Engineering College, because every Saturday we are coming up with the new videos or new live session lectures on different important topics from different subjects, right? So if you have any doubt, kindly comment down. And what I will do, I just, because in shorter span of time I can solve hardly 1 or 2 questions. So what I will do, I will give you some 3-4 extra question in the description box shortly, right? So see you next time. Till then, take care. Bye bye.